Let's take a look at this worked example before moving on to the class example. A 1963 earthquake in Macedonia measured 6.9 on the Richter scale. 1 year later, an earthquake in Alaska had 200 times the intensity. Determine the magnitude, which is the Richter scale value of the Alaska earthquake. So this time we're actually given how many times as intense the Alaska earthquake was than the Macedonia earthquake. So we could start by setting it up in this way, where the intensity of Alaska divided by the intensity of Macedonia is equal to 200. And then for both of these intensities, we can write in what we know as far as the equation is involved. So I is equal to I naught times 10 to the power of m. And remember, m is our Richter scale value. So the intensity for the Alaska earthquake would be IO times 10 to the power of x, because we don't know what that intensity is yet. And then over IO times 10 to the power of 6.9, because the Macedonia earthquake was 6.9. So then we're left with 200. That's how many times as intense the one earthquake was than the other, is equal to 10 to the power of x minus 6.9, because we had 10 to the power of x divided by 10 to the power of 6.9, so you can subtract those exponents. Now, the next step is to convert this to logarithmic form so that we can get this x out of the exponent. So log base 10 of 200 is equal to the exponent, because log solve for exponents. And then solve for x, rearrange and just add 6.9 to both sides. So now if we plug this in, we get approximately x is equal to 9.2. In other words, the Alaska earthquake measured 9.2 on the Richter scale. Now let's take a look at class example 3.65. An earthquake in Loma Prieta, California in 1989 measured 7.1 on the Richter scale and collapsed a section of the San Francisco-Oakland Bay Bridge. Determine the Richter scale value of an earthquake that had 1/2000th the intensity. So we are going to want to put our smaller number, the intensity of the unknown earthquake, over the intensity of the Loma Prieta earthquake, which makes sense because I have a small number over a large number. That's what's going to give us this 1/2000. Now at this step, we haven't shown the IO as we did in the worked example above, but we could have, but we've just skipped that step and we've canceled them already. And you see that we have 10 to the power of x, where x is our magnitude. This is the magnitude of the unknown earthquake. And in the denominator, we have 10 to the power of 7.1. That's the magnitude of our Loma Prieta earthquake. And that's equal to 1/2000. Now, since I'm dividing, we can subtract our exponents. So, as before, 10 to the power of our m1 minus m2, or Richter scale 1 minus Richter scale 2, really is telling you how many times as intense the earthquake is. But in this case, our times as intense is actually going to be a smaller number. So now from here, let's convert this to logarithmic form. So we have base 10, so it's going to be log base 10 of 1/2000 is equal to the exponent, x minus 7.1. And then add 7.1 to both sides. So the magnitude of our earthquake is approximately 3.8 on the Richter scale.